Okay, so this is problem 4.33, and this is one of your actual problems that you need to do from the back of the book. And so I encourage you to try it first before watching the video. But if you're still struggling and you don't know how to figure this out, then you can, of course, watch the video, and there are more tables, 4.34, that he has you to do for the back of the book problems. And this is a really good way to reinforce where all of the information is on our element squares. So here I have an element square, we'll call it. And we're going to talk about where you can find all of this information. So we have the name of the element, the symbol, atomic number, mass number, and all of that is available. So let's highlight that. All of these you can find on this square or on the table, which I have down here. So all of these squares tell you the name of the element, the symbol, the atomic number, and the mass number. Now, the one in our classroom does not tell you the name of the element. So you have to memorize, I think, the first 49, 50, 54 of them, I think, is what you need to memorize. I'm not sure. You might want to check with PK on that. But you do have to memorize several of the first several, I don't know, 80 or so elements on the periodic table. And then up here, I have some math that we can do to figure out the rest of the information. So we're going to highlight that and let's do purple. So these we don't see readily on our atomic square on the periodic table, but we can figure it out from this information right here. All right, so let's get started. The first sim gives us the symbol, which is Zn. So hopefully you've done some memorization and know that Zn stands for zinc. And it wants to know zinc's atomic number. So remember that atomic number is the number of protons, and that never, ever, 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 ever changes. Zinc will always have the same number of protons. So we come down to our periodic table. Here's zinc. And just look at it for a second. How many protons do you think zinc has? So here's zinc's atomic number. And if we look up here at bromine, sometimes you'll see it on the upper left-hand side. And remember on our isotope, instead of the top part, it's the bottom number. So this is where we're going to find our number of protons or our atomic number. So the atomic number for zinc is 30. And it gives us a mass, but we can also see a mass down here. This zinc has 65.38, but it's telling us this zinc is 66. Remember when we learned about isotopes and that all of the numbers on the periodic table that concern mass are just an average of all of the different isotopes of that element. And what changes the mass is the number of neutrons that hang out in that particular isotope. So we have a mass number of 66 and we have an atomic number of 30. We can tell the number of protons from the atomic number, which is 30. So it will always have 30 protons. That will never change. But the number of neutrons can change for each element. In fact, all elements have different isotopes with different numbers of neutrons. So let's make a note of this. Can change. This number can change. This one does not change. Doesn't change. Sorry, my handwriting's so awful. And this one is going to equal the number of protons in a neutral form of that element. We'll talk about that in a minute. Okay, so for zinc, we know its atomic number and we know its mass. So we're going to go up here and we're going to look at our equation that PK taught us about. And that is the atomic mass minus the atomic number equals number of neutrons. And that's because our atomic mass equals protons plus neutrons. Because elements get all of their weight from their protons and neutrons. Electrons don't have very much mass, and so we don't even consider it when considering the mass of an element. But we do look at protons and neutrons when we consider the mass. So if we know the number of protons and we know the total mass, well, then it's just basic arithmetic from there. So it would be 66 minus 30, and I don't have my calculator pulled up, so I'm going to use my phone calculator. So 66 minus 30 gives us 36. So we know the number of neutrons for zinc with a mass number of 66, or I guess we could say the isotope 66, is 36 neutrons. Now, the number of electrons in these neutral elements when zinc is hanging out by itself will always be the number of protons, which is also the atomic number. So here I have number of protons, or the atomic number, equals number of electrons. So if we have an atomic number of 30, how many electrons does zinc have? He's going to have 30 electrons. Now when zinc becomes an ion of itself, it's going to lose some electrons, and that's going to change the number, but we aren't talking about that right now. We're just talking about zinc as if it were by itself. Okay, so the next one does not give us the name or the symbol, but remember that the atomic number is also a name badge. So if we know the atomic number, we can find its name. So we're going to go find the atomic number 12, which is the number of protons, and that looks like it's magnesium. So we look here at this atomic number, which is 12. I'm just going to write mag. Oops. I think it'll fit for me. Here's its symbol. Now it has 12 neutrons, and so, or 12 protons. Now the mass number we could get from here, but we want to check first, because if I look over here, it looks like it gives us the number of neutrons. So I don't want to just write down this mass, right here, because remember that the number of neutrons can change, which means the mass can change. And all we have to do is add the number of protons and neutrons to get our mass. So our mass is 24. And then our number of protons, well, we now know it's magnesium, but even before that, we knew its atomic number, and its atomic number is its number of protons. So we know it has 12 protons. And we know that number of protons equals number of electrons, so it has 12 electrons. Okay, so potassium. You would have to know that potassium's symbol is K in order to be able to fill this one out. So again, go and memorize your symbols and your names. So here's our potassium. Its atomic number is 19, so that tells us two things. What does that tell us? Can you think about that? Our atomic number tells us the number of protons, so let's just write it down, and the number of electrons. And now we can find its mass number. We know the number of protons, we know the number of neutrons. We add those together, and we get 39. And yes, I did use my calculator just to make sure. Okay, the next one doesn't give us a ton of information, but it does give us the number of protons, which is essentially the name badge, right? Number of protons is the atomic number. So our atomic number is 16. Let's just write that in now. And if we come down here, find 16, we find sulfur. So now we know its name and symbol. We can find its mass number because we know the number of protons and the number of neutrons, and we add those together and we get 31. And remember, the number of electrons always equals the number of protons, or the atomic number, because those are the same things. So we have 16 electrons. And then last, we have a mass, which doesn't tell us much, but we do have the number of electrons. So the number of electrons equals the number of protons, which equals the atomic number. So our atomic number is 26, which means that our number of protons is 26. So let's go and find number 26, and we get iron. It already gives us a mass, but what we need last is the number of neutrons. And can you remember how we can find the number of neutrons? So number of neutrons is just mass minus atomic number. So we have 56 minus 26, which gives us 30 neutrons. So the takeaway from here is you need to memorize, I think, the first 80 or so elements, their names and their symbols. You don't need to memorize their atomic number or their mass. And I would check with your lab professor or PK to find out how many exactly you need to memorize. So that takes care of these two boxes. The number of protons is the same as the atomic number, which can be found right here. Or if it's an isotope, it's the bottom left. The mass number is the number of neutrons plus protons, because those are the only things creating mass in an element. Number of protons is the same as atomic number, and it never ever changes. We can find number of neutrons by subtracting number of protons from the total mass. And number of electrons in a neutral element found on the periodic table is the same as the number of protons.